Okay. If you're just tuning in, well, of course you'd just be tuning in. We just had our little episode, I would say, of suppose we should do something, and look like a bunch of big green guys and green gals, because there's She-Hulk too, right? A lot of in the Incredible Hulks in here and She-Hulks in here. I say Hulks, not Hawks. Hulks, okay? You get the perception that, what was it? Leave Hulk alone and Hulk smash, and then the other one was, I know we can do better than that. But we're going to try to pick out concepts that would perhaps be good for yourselves. And if you're not coming up with those questions, fine. We will find something to do. Just because for all of those individuals who have a pet dog, it's something that you know, love, and care about. Us as staff members, why would that be any different for you students that we all know, love, and care about? We are here to help you out, okay? So, with that, something that you have not asked yet, which I am totally baffled on, because I think is some of the toughest part of this semester. So close, not the gas laws. And we will do both of these kind of like they are intertwined. Kind of like the jugular veins are intertwined. Okay? Because if you tilt your head one way or the other, what was on the outside is now on the inside. That's just the way the man upstairs designed us. If you want to know what that means, you would have to take human anatomy next year to figure that out. Yeah. Just like if you pronate your hand, what was on the outside is now on the inside. If you supinate it, what was on the outside, on the inside is now on the outside. Is that right, or did I say that backwards? Okay. You're just saying that. Okay. All right. Do I need to go press that button again on that Hulk and just say, Rrr! Okay, two things that I'm surprised that we have not asked. I keep looking down at this little box here because I know sometimes the batteries can run out of power, and then I'll just stand up here and it looks like this. Oh, gee, you make such a good mime. Two things. Some of the most difficult thing, and maybe all of it was difficult. I don't know.
It's not something to do with like the tree or whatever.
No. Nope. I would say, no, well, indirectly. I would say towards the end of January and somewhere in late March or early April. Probably late March. See, I need the privacy of a phone book to take this off so you can see my S for Superman under here. Because either I got to come over there and look at it.
I don't want to call it, but the equation here is P, pressure, velocity, volume, and the constant, and temperature.
That's one of them. What is that?
I have no idea what it's called.
Well, nobody knows what it's called. It's what you just got to know what it does. It's something ideal. The ideal gas law. To me, that was probably the toughest aspect of this semester. And then something had predated that, which was in January. Not just mole to mole, mole to mass to mass. Yes, we've covered that. It's where you are interpreting a mole-to-mole ratio to see what might run out first. Limiting reactants. Who remembers limiting reactants? See, now you remember how much I hated that. See, if we're saying that we hated that, then it means we're doing something right here. Yeah. Okay? You three, tell people to start flexing their zygomaticus. Wow, that was pretty good too. That was just like that. Smile. Let's see that enamel. What's enamel? Is that on a camel? Camel enamel? Not camel enamel. No? It's something that a dental hygienist or a dentist would know. Enamel, it's found on your teeth. So it makes them shine nice and white and bright. Just shut up and get to what. Whatever we say, right? See, I like that. All right. So, and it's really difficult to do a limiting reactant problem with just writing something up on the board because sometimes the math will not work out. Okay? How many phylums are over there? I thought I heard it. Wasn't there 5 lines? I'm just seeing who's listening from yesterday. They all have a backbone, so they are vertebrates. That's right. Just trying to loosen things up a little bit here. Merry Christmas. Oh, don't use this marker. Okay. All right. Okay. Hydrogen gas can be produced in the laboratory by the reaction of magnesium metal with hydrochloric acid. Okay? So, magnesium metal, what is that? Okay, so what's the symbol for magnesium? Okay. Then hydrochloric acid, that's what? Well, see, when you say the Cl, that's right. What's the charge of the chloride ion? -1. Charge of hydrogen, +1. Okay. So what type of reaction would this resemble, do you think? It's a single replacement. Okay. So what is this what's this magnesium going to do to that hydrogen? It's going to replace it. Now, should we not have gone any further? Probably one of the number one mistakes that people are going to make when they finish this reaction is possibly going to be what? Why is that so important? You're right. Because it's diatomic. So this magnesium replaces that hydrogen. And then, like you correctly said, put that 2 behind there because it's by itself. It's a gas and it's diatomic. Is that right side correct? No, it is not. Okay? So magnesium's +2, chloride is -1, so we need 2 of those. Okay? Then, the next thing we should do with this equation is what? Okay? So we've got 2 chlorides and only 1 chloride here. What are we going to do? Okay? And that would be your I want to say it or right at the same time, and it's causing a brain fart. So if you want to call it that. So is that it? Yes, that would be it. All right. So then going back to the rest of our problem here, identify the limiting reagent or limiting reactant when 6 grams of hydrochloric acid or HCl reacts with 5 grams of magnesium. So if we have 5 grams of this, 6 grams of that, okay? Who would be able to knock this out? So I don't know why I looked that way because I was going to say rut row. Is it really a rut row or is it front row? Or could we do this? Second row. You're the only one that hasn't done a nonverbal. Okay. Okay. So for those of you who wants to volunteer to come up here, said yes, I know how to do this. Or is it the only individual with their hand up? Oh, I'm not that smart. Why did I raise my hand? Dang it. All right. There's 2 ways you can do this. Remember, you can do your battleship method, or what else could you do? Well, you're going to do that anyway, convert them to moles. What else could you do? You could pick one of these over here, okay? And probably hydrogen would be the simplest. In other words, you could convert 5 grams of magnesium to hydrogen, and let's just use that as an example and say that will produce 5 grams. I'm just doing that as an example. If we did 6 grams of HCl, might produce 3 grams of hydrogen. So I'll put that in a box. So for instance, if this makes 3 grams and this makes 5 grams of hydrogen now, which one of those is your limiting reactant? The HCl is, because it's producing less. Now, I made that up. I don't know how accurate. I tried to do the math in my head really, really quick. Okay? All the voices trying to tell them, shh. All the voices, shh. Yeah, yep. Close out of them tabs, and you never know which voice is talking, and yeah. That was funny. Well, thank you. Helium, helium. Okay. So what method do you want to do? Do you want to convert them to grams of hydrogen, or do you want to do your battleship method? Which do you feel more comfortable with? We can do both. Okay. So what that means is your battleship method, you're taking 5 grams, okay, and you're going to convert this to moles of magnesium. That's the very first thing you're going to want to do. 5 grams magnesium, okay? So for every mole of magnesium, how many grams is that? Is it 24? That doesn't sound right. Okay? Huh. Oh, I was right. Oh. Oh my gosh. I was right. Oh. No. Okay, I'll keep going. All right. So you're going to take 5 and divide that by what? 5 divided by 24. Okay? So 5 divided by 24 gets you approximately 0.21. Okay? 0.21 moles of magnesium. Now, How should you label that other than saying moles of magnesium? That is what you have. You have this amount. Okay? So now we're going to do the same thing with our HCl. We're going to convert that to moles now. So 6 grams of HCl. Okay? So for every mole of HCl, how many grams do you get? Like that?
Well, it's 458. I don't know if you want to round that up or
458, you said? Yeah, we're good with this.
458.
Okay? So 6 divided by, well, it's 1/6, so it's probably 0.15 maybe. 6 divided by 36.45, 0.16. There again, this is what you have. Okay? So you have 16 cents of HCl and 21 cents of magnesium. Can we determine our limiting reactant by this? You're shaking your head no. Why is that correct? If you're going to do that, yes, but we haven't played our battleship yet. Because we've got 0.21 moles of this, we're going to fire it at the HCl. Then we're going to do the same thing and play battleship and shoot at the magnesium. Okay? So what that means then, okay? Okay? How do we cancel out moles of magnesium in this step? Moles of magnesium on the bottom. Okay? And then what goes on top? Specifically, what about HCl though? No, not quite. Why are you right? It's a mole to mole ratio. Okay? And since we see that a mole over a mole means we're going to put a 2 here because of that number 2. Okay? Don't put 2 here, even though it's labeled HCl. Why not? Because this is not a what ratio? That's not a mole to mole ratio. So now what we could do is take 0.21, 0.21 times 2. Of course, it's going to be 0.42. So once we do that, 0.42 moles of HCl, 0.42 moles of HCl is followed by what 3 letters? REQ. Okay? And of course, we can put it down here, 0.42, so we know where it came from. So what we did is we shot at HCl. HCl will retaliate, shoot at the magnesium. Okay? So for every mole of HCl, you get a mole of magnesium. We've got a mole to mole ratio. Why is that important? We've got to put a 2 on the bottom. So that's probably 0.08 if our math is correct. 0.16 divided by 2. Okay, 0.08. So 0.08, that goes here. 0.08. And That is REQ. So how do we, now we have enough information, how do we determine our limiting reactant with the numbers that we see? Okay, it's a matter of interpretation. We had 21 cents of magnesium. How much do we need though? Do we have enough of this? Yes, we do. How much HCl do we have? We have 16 cents worth. How much does it cost? 42 cents. Do we have enough of the HCl? No, we don't. So everything going forward, you should star, underline, whatever. Put this over top of that. Because if we're looking to see how much hydrogen is going to be produced, you can do that with magnesium to see how much, but you're not going to get an accurate answer because you are limited on what you can produce because of this. That's why we calculate a limiting reactant. Okay? Now, aren't we glad we went over this now? So now that we've done that, okay, let's say there's a part B and a part C. Oh boy, we can't wait, can we? Okay, so let's, if you wanted to do this a different way as a review, how many grams of that will be produced? And since this is a gas, we could say this is produced, how many liters of this are produced? X amount of liters, okay? Can we erase all of this? We don't have to erase all of it. We're not going to reinvent the wheel here, but we're going to take quite a bit of this content out of here, okay? This for sure we can get rid of, okay? And then we can get rid of this. No, we can't get rid of that. What was I thinking? I wasn't, I guess. Huh. Sounds like at home. No, I'm just kidding. No, that's fine. All right. So 24 grams, 36.45 grams of HCl. So what we want to do is find out how many grams of that hydrogen is being produced. So how are we going to get from this side of the equation to this side? By going through what ratio, of course? The mole ratio. So how do we get rid of moles of magnesium in this step? Okay, so moles of Mg to moles of what? Nope, we did that already. H2. Don't do just like this, because I can almost guarantee you, if you write it like this, what is going to, we got to do a mole ratio yet, I understand that. But what's going to happen if you keep going in that manner? You're going to be off by a factor of 2. Why would that possibly be? Because it's H2, not just H. Because what's going to happen is if you do that, you're going to do this. Well, I didn't need to write it twice, but see, once you do that, then you're not going to make that. See, that's just by doing that by habit. It just comes natural. You're going to be off by a factor of 2. 2 there, 2 there, 2 there. Okay? What about this mole ratio now? Do we need any coefficients? No, we don't. So 2.02. So everything is canceled. We're in grams of hydrogen, and that's what we want. Okay, so if we take 5 times 2.02 and divide that by 24, we're going to get 0.42 grams. 0.42 grams of H2. Okay? Well, we got to do the same process here. So for every mole of HCl, we're going to get a mole of H2. 2 on the bottom because of this 2 here. Okay? Then this last step is the same. So we take 36.45 times 2. That gives us 72.9. Okay? And then 6 times 2.02. That gives us 12.12. Okay, so this is on top by taking 6 times 2. This is on the bottom, 36.45 times 2. And then once we divide those, we get 0.16. Okay, this in an indirect way tells you what your limiting reactant is. But you have to go all the way back. So which, obviously this number's smaller. So that means since this is smaller, back up. And lo and behold, what do we see here? Do these match up? Yes, they do. It's just a different way of solving that. I mean, does that mean mind blown? I get rid of the voices. They're gone. Okay. Okay. Now, how do we find how many liters of hydrogen are produced? You don't have enough information right now. Okay? You can make this as simple or as complex as you want. You might. See, that's a yes or no question. It depends. There is a certain constant that we used with gas stoichiometry.
What's his name's number?
Not Avogadro. I think some of it, I think we're starting to say it though. It's a number. You're going to say, I knew that.
It's not the 1.325.
No, it's not that. That's converting to atmospheres from kilopascals. That is a constant, but not the right constant. Nope, that's the R constant. We can give you a clue. It's kind of like a caliber of a rifle. You're not going to take down big game with this rifle. I don't. Could you do it with a hollow point? Probably not. I mean, if there's a, which one of you? Who said 22? I don't. If you got a big angry bear coming at you, I don't think a 22 is going to do much. Correct? Yeah. So, yeah, so it's 22 point something. 22.4, okay? So what we mean by that is this is part C of this problem, okay? So what that means is part A was determining the limiting reactant. Part B could have been how many grams of that hydrogen. And that's also a different way you can calculate your limiting reactant. And then part C would be how many liters of that is produced. So if we're going to use 22.4, which we can, you would have to presume that this hydrogen is measured at what? Do we want it measured at STP? Okay? So what a question might say is, if there is 6 grams of HCl, how many liters of H2 are produced at STP? Okay. And when we reflect upon that, if it was not measured at STP, what would you need to know? You would need to know the pressure. You would need to know the temperature. And no, not the volume, because that's what we're looking for. But you're given the variables that we would need to know. Okay? So now, do we have dimensional analysis people out there, or are we ideal gas law people? Or do you want to see both? See both of them? Okay, so we'll do the ideal gas law first, which means we know that variable, okay? That we don't know. That we don't know. Do we know R? It's less than 1. 0.0825. And do we know the temperature? Now, the problem with this is 2 things. Yes?
Can you move the art, please? Fake one.
Get out of there. Oh, not this heart. Oh, okay. I was gonna say, what are you trying to do to? No, I'm just kidding. Okay. All right. So we've got a problem. We've got 2 unknowns here. Okay. But when you're doing gas stoichiometry, means you have to be dealing with a what? Is this a gas? It can be, but this is hydrochloric acid in a solution. That's a liquid, not a gas. Okay, so what can you do with this 6 grams of hydrochloric acid in reference to N? Turn it into moles of that, okay? So in that process, we take 6 grams of HCl, and notice we can comfortably start here because it's not 4 steps, okay? How do we get rid of that gram? Put the atomic mass on the bottom, 36.45 grams of HCl. That gets you a mole of HCl. Then in your next step, how do we get from this side of the equation to this side? Correct, but which one goes where in your mole to mole ratio?
The hydrogen goes on top and the HCl goes on top.
Sure?
No. Yeah, I am sure.
Yes, yes, you're sure. Okay, for every mole of H2, you get a mole of HCl, but we're still not done. Why? You're right. Because it's a mole to mole, and our equation up here tells us we need that too. Okay? So then we take 6 and divide by 72.9. And we get 0.0823, okay? Which would make sense because this was measured at STP. And then that means we got to put 0.0823 in there. So that is now gone. So any number or variable times 1 gives you what? Yeah, 1, or the same thing. So now it's safe to say our volume is going to equal, because this is on the left-hand side. Here's what we're looking for, and pressure's already 1. So 1 times V is just going to give you V. So V equals, okay? And then upon doing that, if we take 273 times 0.0821, 22.4. Okay? That is if you are doing the ideal gas law. But what about if you were dimensional analysis, which I prefer to do dimensional analysis, which means, okay, we don't have to change a whole lot here. We're going to get it all out of the way in one step. We've got 6 grams of HCl. Same thing, 36.45 grams of HCl to give us a mole of HCl. Then for every 2 moles of HCl, we get a mole of H2. And our final conversion, since it's measured at STP, how many liters of a gas are measured at STP? Gangster signs, right? I did this earlier. Is this being a gangster? See, I thought it was. You gave me bad information.
They're lying to you.
I don't think he would do that. This?
It's a win.
Oh, okay. Anyway, 22.4. Okay? So now, if we take 6 times 22.4 equals, and then divide that by 76, was it? 1.76. Something's not.
72.9 is divided by.
I did 76, but that's not going to change it very much. Something is wrong here. $72.9. 134 divided by 72.9. I get 1.83 liters of H2. Something is not working out here. So I'm going to have to take a peek at that. I think the mistake was in here, not over here. But I will get that straightened out by tomorrow. Okay, so we're running out of time. Ran a little longer than what I would have thought, but that's my fault, not yours. So we'll catch up to you next time.